Today we're going to be explaining why compression of data is often necessary when transmitting across a network. But before we do that, we need to talk about and identify what compression is. An extensive definition of compression is that it is a set of steps for packing data into smaller electronic space. This can be whatever data type you're using, megabytes, bits, data bits, while still allowing for the original data to be accessed and used. This is often achievable by eliminating the repetition of identical sets of data bits. This is called redundancy, and there's different ways to eliminate those identical sets of bits that I'll go into later. Compression results in a much smaller storage space, and therefore it uses up less bandwidth when transmitting over the network, and that causes faster communication. Compressed data often is more effective on our mobile phones and portable computers as they have less storage capacity than PCs. There are two types of data compression, lossy and lossless compression. Lossy compression results in a high degree of compression as it removes those identical data bits that we were talking about. They're usually undetectable to the human eye or ear, as a lot of formats of data compression are often JPEG, MPEG, and MP3. So it's also audio files, video files, photographs. Advantages of lossy compression is that it results in smaller compressed files as it removes data bits. This causes quicker file transmission, and it's usually undetectable to the human eye or ear, as in audio files it can delete wavelengths or remove wavelengths that are not detected anyway by the human ear, therefore saving up on space. It's also supported on many software, which I will go into later. Disadvantage, however, is that the quality of the file decreases and it's unrecoverable. Therefore, if it is compressed, you cannot achieve that quality back again. An example of lossy compression, a practical example that I want to go into. This is a normal MPEG file, video file, and it is 25.6 megabytes. After compression, it is 14.2 megabytes. If we watch the difference, okay. There is a very obvious and detectable difference, but that is because the change in file size was drastic. And the way you control that, for example, as I said, it is supported by many software. This is a data compression lossy software, and you go, after you import your video, you go into the video section, and you can decide what quality you want. And the worse the quality is, the lower the file size will be, and that is beneficial for data transmission and file transmission. Lossless compression, on the other hand, after the file is compressed, it needs to be restored and rebuilt for it to be accessed. Therefore, there's no real data or quality loss because it doesn't need decompression to be accessed. Advantage of it is that if the quality is maintained, the file quality is not decreased. And if the file is compressed, it can cause faster transmission, however, not as fast as lossy compression, and it is recoverable if you use the same decompression framework. Disadvantage, however, is that it results in higher file size and needs decompression, and therefore takes longer. An example of such is below. The decompressed file on the left side uses 10 spaces of memory, whereas if you compress it by grouping together and clustering like data bits, it only results in 8 memory spaces. This is called run length encoding. So why is it necessary? Because it reduces, initially it reduces storage capacity usage, therefore it uses less of the communication bandwidth on your network, and therefore data transmission time is a lot shorter.